with the idea of probability. Now, some of it's pretty simple, some of it gets more complicated. It is going to involve area formulas, so kind of get used to that idea. The basic idea of probability is, to calculate the probability of event, is to find the number of desired outcomes and divide that by the total number of possible outcomes. And you've done this before. This is like a middle school topic. You do some very basic probability, and we're just kind of reviewing that to give ourselves some context. So if we're rolling a single die, what is the probability of rolling a 3? Well, we start with what is the total possible number of outcomes we could possibly have when we're rolling a die? Okay, standard cube die. 6, okay? How many of those results give us a 3? 1 out of 6 does, okay? So my probability is 1 out of 6, or we could represent that as a decimal, which is 0.1666, or that 6 got a lot of control. Or we could represent it as a percent, 16.67%. Okay? We can express a probability as a ratio, as a decimal, or a percent. Any of those are considered acceptable. Another quick example of just basic simple probability. City of Milton has 6,300 residents. By the way, I just made these numbers up, so they are not accurate. Don't take them as truth. 3,400 of which are female. What is the probability of randomly selecting a male resident? So we got to do a little bit of thought here. It's not just using the numbers we got. We got to kind of do a little strategizing, right? Number of male residents. So really what we're looking at is the total residents I can't spell apparently right at this moment. Let me try that again. Let me just try this again. Over the number of male residents, which we're, for math purposes, we're going to have to do the total residents minus the female to get that number, right? So we got to kind of create ourselves a little strategy. So it's 2,900 over 6,300, which would reduce to 29 over 63. And then if we need to, we could change it to a decimal or percent by using our calculator pretty easily, right? So that's just basic everyday probability. And we're not going to have any problems really that will look like that in our homework today, but it builds a framework we can use off of to deal with the idea of geometric probability. In geometry, we do essentially the same thing. It's a ratio of lengths or areas, or technically it could be of volumes too. We just haven't learned volumes yet because we haven't gotten that far. We'll be learning volumes probably later next week, starting on that. Okay? So like desired length over total length, desired area over total area. Okay? But it's pretty straightforward. Number line probability is pretty easy. Given a point is on segment AC, find the probability the point is on segment AB. Well, the total length for us is going to be AC. Now, it's a number line, so we're going to have to do a little work with that. Okay, it's a little hard to see the numbers here, but A is at -10 and C is at 2. So if I go from -10 to 2, how long is that? 12, yeah. That's the total length. What's the desired length? The desired is from A to B. That's from -10 to -5, which is -10 to -5. How far is that? 5, yeah. So my probability is 5 out of 12. It's that simple. Given a point is on BE, we already know B is at -5, E is at 10, C here is 2, and D is at 4. I'm just going to make those numbers bigger so you can see them. Given a point is on, is on, a little typo there, BE, find the probability that the point is on CD. Well, how long is BE? From -10 to 10 is, I'm sorry, BE, from -5 to 10, 15. So that's going to be my numerator, my denominator. Top or bottom? Bottom, that's the whole thing that we're using, okay? What's the probability that that point is on CD? CD is from 2 to 4, which is how long? Careful. Just subtract the coordinates. 4 minus 2 is 2. Don't count. Some people go and count, and they count the number of lines. They go C, D, E. That's 3. No, in number line, that's not how we do it, okay? We count the spaces. 1, 2. Okay? So be careful with that. So 2 out of 15. That's my probability. So number line, pretty straightforward. I don't think you'll have any problem with the number line problems. The area problems get a little more interesting. Again, the formula is desired area over total area. It says, given a point is in the outer figure, find the probability it is in the shaded area. So that means I need to come up with a strategy, just like we did before. I need to come up with a strategy of knowing exactly what those things are. So the total area is my outer rectangle, right? How can I calculate my shaded area? Well, I want to have a strategy for that. So before I start throwing numbers at things, I want to have a plan. All right? It's like building a house or anything important that you want to build. You don't just go in and start nailing boards together. You got to have a plan first. You want it to come out right. So we make a little bit of a plan here. Okay, the shaded area, I'm going to take the whole outer area here, the outer rectangle, minus what? What are we taking away from that area? The small rectangle minus what else? The circle. Okay? So this gives me a plan on what I need to calculate. So before I start crunching numbers, I have a plan. I know where it is I'm going. That's important. And now, with these shapes, there's not a whole lot of challenge here, but we got a little bit of stuff to figure out. Let's start with the outer rectangle. Okay? The outer rectangle is a rectangle. Rectangles are easy. We just have to do, what's our formula for rectangle? Base times height, right? So how long is my base? 17, and my height is 6. So 17 times 6, that's 60 and 42. Is it 102? No. Is that? Yeah, it is 102. Good. Okay, and that outer rectangle is still here, too. Now I have to subtract the smaller rectangle. Okay, that's easy. That's 2 times 7, that's 14. Now I have to subtract the circle, but I don't have any measurements indicated on that circle. 17 times 6? What's 180? Oh, that's 180 degrees, 360 degrees. But I want the area. What's the formula for area of a circle? Area of a circle is pi r squared. Okay? And although I'm not given any measurements in the circle, I do know that the distance across the circle here is the same as the side of my rectangle, which is 6. Is that the radius? No, it's a diameter. So the radius is 3. So pi r squared, 3 squared is 9, so that's 9 pi. And now I have to actually calculate that. I'm going to put this in my calculator. So I'm going to take one. Now I got, see how the strategy told me what I needed to find. I find the numbers. Now I start crunching them in my calculator. 102 minus 14 minus 9 pi is 59.725 whatever. I'm going to divide that by 102. And I get about 0.5855. Or 58.55% chance. My probability, if I pick a random spot in that shape, the probability of that spot being in the shaded area is 58.55%. Because that's the proportion of the area that's shaded. That's how we do a geometric probability problem. All right, let's try this one. Same question. Find the probability if I pick a point at random that that point is going to be in the shaded area. Well, okay. Same strategy, same thing we're going to do is start with a strategy. What is my total area? My total area is what kind of shape? A circle. So the area of the circle, okay? The shaded area, so that's my total area. My shaded area, I take the area of the circle and what? Subtract the area of the octagon. Okay? Still can't spell today. Okay. So I need to find two things. I need to find the area of the circle and the area of the octagon. Well, what do I know? I know a radius of both shapes. For the circle, it's pi r squared. R is 5, so the radius squared is 25. 5 squared is 25, right? Okay, yeah, I don't want the decimal, right? We'll just leave it right now. And just because if we leave it exact for the moment, it's just a little nicer. All right, now we need to find the area of the octagon. Ooh, that's a little messier. So whenever we find the area of a polygon, this is kind of now a review of what we've done the last couple of days. The area of a polygon is perimeter times apothem divided by 2. I only know the radius, but that's okay. Knowing the radius and the fact that it has 8 sides is enough, because I can draw in my apothem. Here's my angle. Okay, there's my apothem, and this, I'll call this O for now, is half of the side. Why am I calling that O? Because that's the opposite side of the angle that we're going to get, which is this angle right here. How do I calculate that angle? We gave you a formula for that both on Tuesday and yesterday. 360. No, close. 180 divided by the number of sides. Yep. And when I do that here, that's 22.5 degrees. 180 divided by 8 is 22.5. Mm-hmm. It is, isn't it? 22.5. Divided by 9 would be 20. Yep. Yeah, octagons are actually nicer than octagons when it comes to that calculation. Kind of strange to think that, but it is. All right, that's fine. Now I've got my angle. Now that I have my angle, I use my trig functions. Let's get off your phone. In fact, why don't you set it over on the table a little bit? Thank you. Leave it there. All right. So now what we're going to have to do is use our trig functions to set this up. And that's our Sohcahtoa. Okay? So a lot of times in polygons, we have to do this. We don't have to do it with squares. We don't have to do it usually with octagon or hexagons or equilateral triangles. But for octagons, septagons, nonagons, all those other shapes, we generally have to use our trig functions. All right? So what we're going to do is we're going to start by looking at this. Okay, sine is opposite over hypotenuse. So sine of the angle equals the opposite side, which I don't know, over the hypotenuse, which is 5. That's my radius in this case. Well, I can solve that. Okay, that's not so bad. multiply both sides by 5, because that constant's in the denominator, cancels. I get 5 times sine 22.5 is 1.913. No, you can't do it that way. Okay, the 5 multiplies the value. Remember, sine 22.5 is a value. I can't just multiply 22.5 by 5. Okay, I don't multiply the angle by 5. I multiply 5 times the value sine 22.5. Okay, so be careful about that. That's different. What? 1.91. Now, if that's this side, 1.91, then I can find my perimeter, because that's half a side, so I double that, 1.91 times 2. So a side is 3.82, and there are 8 sides like that. So 30.56 is my perimeter. Awesome. Okay? Now I need the apothem. We've done the sine. Let's go to the cosine. Cosine of 22.5 is adjacent, which is also the apothem, over the hypotenuse, which is 5. Again, we multiply both sides by 5. Not the angle gets measured by multiplied by 5, but the value of cosine 22.5. So 5 cosine 22.5. My apothem is about 4.62. Great. Now I've got the information I need to find the area of the hexagon, because I have the perimeter and the apothem. Area is perimeter times apothem divided by 2. So my area is a perimeter times the apothem divided by 2. So 30.56 times 4.62 divided by 2, I get 70.59. So a little work there to find the area of the hexagon. Or, I'm sorry, the octagon. A little bit of work. Now I have to actually do my math. First thing I'm going to do is I'm probably going to decimally approximate that 25 pi to make my life easier. So 78.54. So I'm going to take 78.54 minus 70.59, which is 7.95, and divide that by 78.54. And I get about 0.101, or 10.1%. So my probability of picking an area, a spot in the shaded area, given that I'm inside the big circle, is about 10.1%. That's about 10.1% of the area. Okay? So again, we get this opportunity to use our area formulas and to calculate some values. And we're going to be using all sorts. We're going to be using triangles, we're going to be using rectangles, parallelograms, squares, and regular polygons, circles, all those different shapes. It's a way to practice all this stuff. That's geometric probability. So the circle part was easy. The hexagon part was a little more challenging. Here, there wasn't anything that was super challenging. We did have to remember our area formulas. That's why they put this section where we did this here, because it's a great review of area formulas. Next week, we're probably looking at Monday being a review day, and if things go, I think, according to plan, then Tuesday is supposed to be our quiz day in here. And I think what's going to happen in here is going to be the same thing that's happening in the other geometry classes, where instead of doing a half chapter test and a half chapter test, or half chapter quiz and a chapter test, we're doing basically 2 quests. So like instead of, you know, a 50-point quiz and a 100-point test, we're going to have 2 75-point evaluations this time. Okay? So that's kind of the way that it's going to work this time, if she does things the way I think that things are going to be done. So that's what's coming up. But these are the types of problems we're going to work with. Now, I'm going to put this podcast online. It's going to be on YouTube. It's going to be on a link to it on the Schoology page, and I'm going to leave these notes on Schoology as well. I'll upload those. That's what we're going to be working on. Again, today, considering we had only 10 people turn in their homework, I'm expecting everybody in the remaining period that we have to be doing nothing but working on this homework. Or you could be working on yesterday's assignment if you didn't get it done. But let's leave the phones away. Let's leave the computers away. Let's leave the books away. All that stuff. All right? Let's just work on the assignments. I'll get you those assignments in just a second.